I guess that everyone sees me. I promised Gunnar to take give an introduction and information about everything in the beginning. So just to inform everyone that this seminar will be recorded and then published. So if you don't want to be seen here, then you should know that it's recorded and you can, in that case, leave. Today, I will talk about the new sustainable, the new TIG that have been started in the Start EU Alliance. My name is Mikael Ericsson. I'm working at University of West as a lecturer in robotics automation, teaching mainly these objects, but also machine vision, industries digitalization, and so on. I've been appointed for responsible for this new TIG, and it was started quite soon in March. So I'll come back to that. So during this talk, I will have a following agenda. I will present this new TIG, and I will talk about what we have done since we started it. I will talk about who is partner and so on, our KPI and so on. So after I finish that one, I will present a little bit what we have done in the area of sustainable industry and how we have worked with the region here in Sweden in joint projects with the industry, and also say a few words about the results and the things that we have got based on that one. After that, I will open up for any type of questions and so on. So this new TIG, it was introduced at Forest Steering Committee in late March 2024. And during this decision, the steering committee decided to start two new TIGs. It's one which is in sustainable industry, and then also one which is the inclusion and social justice. That means that in Starship we have now 9 different TIGs. TIG stands for Thematic Interest Groups and are, say, cluster of different areas that we are forming around the thematic area and trying to work hard in this region. For a sustainable industry, I have been appointed as the leader of it, and I have a co-leader in Professor Marek Korsier from Krakow University of Technology. So when we're looking at the industry and the industry in the European region today, we can see that we have some major challenges that affects the industry's future. These challenges affect the competitiveness and opportunities for the industry and also for the citizens in the union. When we're looking at it, we can see that we are following, these challenges can be summarized for 5 different main points. It's digitalization and productivity, technical transformation, climate change, focus on value chains and services, and demographic and gender equality. So based on all these 5 points, we can see that large of the industry are affected about this. We know that the digitalization, the transformation from industry 3.0 to 4.0 affects our productivity. We can see that we are changing our production sizes to be more customized, more unique. That means that we are reducing our number of products, but we still have an automation and a higher level automation. In this area, we're also looking into new type of manufacturing processes, also connected to the technical transformation, where we have, for example, additive manufacturing, where we are instead of casting products, we are using additive manufacturing to build the product by melting material. It can be both plastics or metals, but we're also looking into new type of metals, textiles, and so on to use additive manufacturing. So the industry is transforming in a technical way how we are working in this. Then, of course, we have a climate change that affects how we are looking in our supply chains. We are looking into green energy and so on, how we can have lots of industries and so on, but still have a good climate and reaching the climate or environmental challenges that we have. And then we're looking into the focus on the value chain. That means that the industry are not just producing one part, we are trying to add more value to the product and to look into the change and how we are producing our parts. It can be that instead of transporting lots of material from China to Europe in big cargos, we are looking into how to develop and produce the parts in Europe itself, and then shorten the transportation. So it's also connected to the climate change. And then we're looking into the problems due to the demographics and gender equality, or demographics, that we are getting older and older, and our population gets older, and we need to work longer and longer time. And that affects how we are using the industry, because that means that we need to have much more about support and automatic processes and machines and so on in our production. It's also a problem due to that our skills are changing. So the younger population don't have the same type of skill sets that the older ones has. So that is something that we need to build into the production system. So based on this, we have formulated some type of general introduction for this new TIG, sustainable industry. So the purpose of this TIG is to look into the industry and integrate environmental, social, economic, and sustainability principles in all aspects of the industrial, to minimize the negative environmental impact, and also to promote social equity and create long-term economic values. So the sustainable industry TIG will include production, new advanced materials, and develop in collaboration with our institutes and academy. So that is, we will not just focusing on our own TIG, we will also collaborate with other parts. And then we will look into resources or be more efficient in our processes and product development, and to have more services as digitalization, energy supply, and circular business modules. So it's quite broad theme that we have developed for this TIG. Then we're looking into the startup of a TIG. We have in the application looked into different type of prioritized areas for all regions that we have the universities in the Stars EU. And one very big area here is that almost all our universities working is together with the production industry. Loads of it is connected to getting a more flexible industry, looking to more advanced materials, looking into circular economy and smart manufacturing, and so on. So large areas here are working with this type of production technology and production industry. And based on that, we were formulating that this TIG should have this type of definition. When we're looking at the definition, we can see that it is large areas that are connecting to already existing TIGs. We have in the Stars EU, before we started this one, 7 TIGs, and now it's 9. And by looking at the definition on the other TIGs, we have identified that we have common interest in at least 4 of these things. And for us, or for me as a leader, it's very important to point out that I think that we should have a collaboration between the things. So we should not have any competition. And I see that we have a real strong collaboration with these 4: digital transformation, circular economy, energy transition, and entrepreneurship and innovation, by reading the strategic documents that this TIGS has formulated. So I think it's really important that we, when we're looking down to our KPIs later on, really sitting down and discussing with these 4 TIGs, so we can have a joint collaboration and no competition. Then we are today 3 universities or 4 universities that are have so far identified persons that are interesting to collaborate with this one. And I'm very interested to get more people from our universities that says that this is an interesting area, I would like to contribute, I would like to hear what you are doing, and so on. So if you are part here but are not listed here, and you think that this is interesting, I really would like to get your names on the list so we can have a more detailed collaboration. Within the Stars EU, each TIG has got a task to specify a strategical document or strategic cooperation agenda that has been will last for at least 3 years. And during this definition, or what we are going to look at, we have got a number of areas that are identified as really important. So the first one is to look in to see if we can get the joint research project with one or several partners. The second one is to look into the design and implementation of BIPs. BIPs is blended intensive programs, which is short courses for students, normally around 7.5 to maybe 15 credits, where the student getting different type of learning agreements or learning, and on a blended perspective, and then we're going to one certain location and have some physical interaction with each other, and as well as doing elaboration, examination, and seminars, and so on. Another one is also to have short courses or micro-credential to not students, but to people that are working. So we're developing courses both for students and long life learning is really important here. Then it's looking into the Erasmus Plus project, contribute and prepare for Stars EU agenda for research solution, looking into mobility for both researcher or staff, and joint PhD projects, and joint degree programs or double degree programs. So it's a number of things here that we are looking into and discussing. And then it's to be an active part in the Stars EU in the learning and technical committees. We will act as an ambassador and promote our alliance, which is of course quite natural. And then we will look into supporting of a challenge lab and curriculum lab that are part of a work package. I think it's 3 and 4. And then looking through all our activities each year and try to formulate an agenda for the existing year. So since we started this process in March, we have not really been defining all our KPI, but we have at least identified which projects and also try to identify maybe how many number for each KPI. But I would like to highlight this is a draft. It's not defined, and we need to have work a little bit more of a time for it, and also to discuss with our project thematic vertical leaders to make sure that we are in the same directions. And the reason for that is that I can see that, as I said, we need to have a collaboration around a number of areas here. But we have at least identified for a 3 years period that we will aim for having 3 research project, Marie Curie application, etc. We think that we can have a number of thesis work that we have joint supervision, or that we are clustering people from different universities trying to solve the same task in a joint group. We're also talking about having a PhD exchange and joint supervision of the students, that we can have one professor from one university together with another university, and then they are supervising the same students. We know that we need to look into the number of BIPs and short courses, but we have not just defined how many. And here is also a discussion about the collaboration between the different TIGs. When it comes to the number of students mobility, which is a very important aspect in this STARS EU, we don't really know how we should count that at the moment. So that is something that I'm investigating at the moment to see how we should count that, what is counted as a student mobility, what is counted as a student in the BIP, and so on, how we should. So when we're talking about the session and conferences organized with the STARS EU, it's also a discussion connecting to the other TIGs, how we should count that, because some universities may be good to organize one conference, but that can be counted in 2 different TIGs, and how should that be handled? We looked into the number of summer schools, but during the discussion that we had, it was concluded that we don't really think that the summer school is a really good opportunity. So we would like to reduce that type of activities and instead focus much more on the BIPs and the student mobility in other ways, because the experience about the summer school was not really good by the participants in these discussions. And then also come back to our TIG leaders, we need to look into how we should define these collaboration events with our TIGs groups. But it is important to have that discussion. So the long-term action here is really that we plan to propose joint courses. We plan to have education programs and research. We're looking into joint courses, but also joint programs, double degree programs, and joint research programs. Maybe we can find a solution in the long term also to have a joint PhD school or PhD education. But we have a little bit different views on how this should look like, or what the different seminars, how the PhD education is done in different countries. The TIG is very convinced that this will strengthen the cooperation of teaching teams, and we also think it will attract students and increase their interest in mobility. And we think that joint diploma will be very attractive for our students. So our next steps here is to finalize our strategic cooperation agenda for 2024 to 2027. We have a good way, but we need to still define how we should use and work with a KPI and also making plan for reaching this target that we have identified. Then I will present this TIG for our steering committee and also for the other TIG leaders to get their view on it and also to discuss the collaboration. And then we have discussed to have in real life meeting somewhere in September for the interested partners, but we have not yet defined the date, we have not defined the location. So we are also looking into the timetable for the Stars EU to see if we can use some of the our events that exist to organize this. So that is the concluding of the TIG, and I think we can take some of the question maybe afterwards. So instead, I will jump a little bit to some of the things that we are working in University West to, in connection to the sustainable industry and the region and so on, how we have worked and with companies and using external funding to increase the activities and collaboration between the students, the industry, and the researchers. So when we're looking into the research area that we are connecting to this sustainable industry, I can see that we are a really strong group within production technology. They're looking into materials and manufacturing, mainly welding, thermal spray, and additive manufacturing. And then we have one area which is production system that are looking into flexible automation as well as the control system of different type of processes, mainly welding and additive manufacturing. At our department, we also have strong groups in computer science. They are looking into AI, cybersecurity, and computer interactions. We have electrical engineering, and then we have industrial work integrated learning. So, and as you see, they are more connected to the other things. So, but we have interaction between this. So I will talk about a research area that we have developed based on external funding and our internal funding. It's called Production Technology West. It is a research group that consists around 80 people. We have people from all over the world working here. It's a professor, senior researcher, PhD student, engineering student, research engineers, and administration. And we are sitting down in a special location. It's 1.5 kilometers outside the main campus. But in that building, we have also other type of companies, both SME companies and large enterprises sitting, and we are sharing equipment, we are sharing the work floor, we are working jointly in different type of applications. So we have a large mixture of competences around the staff, and we are running more than 60 projects here. I mentioned the areas that we're working on. So it's a thermal spray, welding, additive manufacturing, flexible industrial automation, operation and supply chain management. This is an area that are external funded. So we are looking into funds from both Sweden, local region funds, national funds, and EU research funding. And we also have very large and very close collaboration with the industry and lots of co-production of the research material or research results. This building is called the Production Technology Center, PTC. It's located in Trollhättan. So I would say PTC in many cases here. So in one part of this research center, we have worked really hard together with region to get external funding using the EU structural funds together with funding from the region to build up a good demonstrator area, so we can do different type of demonstrators. One important part here is to involve the SME companies, both to be part of the work that we're doing at the research center, but also to involve them in different type of projects. And we can see small pictures of the production center, and what we're seeing here is really that we get some automation line where we have both students, we have lifelong learning from companies, but we have students from the companies. We are doing a research project, and we're doing development project in joint collaboration with the industry. So we are producing lots of material, and one part that we are looking into is to attract the smaller enterprises to be on P2C. We are creating and developing industrial networks where we have a number of companies involved. And what we're doing with this network is that we are having meetings with them. We are finding and discussing their problems. They are identifying maybe we need to do some type of new additive manufacturing process. We are interested to look into a welding process. We are interested to see how we can be more flexible in our automation, or we can use our machine vision system better, or how we can do grinding or whatever. So we are together with companies identifying a number of companies that are interested in this type of problem. And then we are developing, building a demonstrator at PTC based on the need from the companies. It's important to say that this is not like a consultant, it's just that we are formulating a problem that are common for all these companies that are involved. Take a grounding problem, for example, we can look into different type of tools, and that is generic for all the companies that have a problem. It can be different materials, it can be how to use the force sensor, etc. And then in this development building of a demonstrator, our research engineers, our researcher, PhD students are involved together with people from the industry. And in that way, they are doing this co-production of the knowledge. This knowledge, as well as the technology that we're developing, is then introducing back to the companies, introduced to the networks. We are using it as maybe a case study. We are using it as a collaboration for our students. We introduce it for our professional courses for lifelong learning. So the knowledge that we are building here in this type of demonstrator is fed back to the region or the companies in the region to really strengthen their competitiveness in the area. So building this competence is really important, and University of the West has a long tradition to build this type of courses that we are offering for the companies. It is free courses that are taught during a short period. It's just 2.5 credits on the master level. But what we are doing is that we know that lots of people that are working in the industry, they don't have a Bachelor of Science or that type of degree. But so we are validating the competence that the person has, and that can be that we need to have at least a number of years of work experience, and maybe working in the same area as the course, and so to be able to fully understand that it will be have the ability to understand and follow the course. What we have also done with these courses is that we have not just sitting down by ourselves as a lecturer defining that I would like to have this course. We have done loads of co-production of the knowledge and the course structure together with the industry. So we are meeting the HR, the managerial team and so on, talking to them about what type of skills or what type of knowledge do your workers need to have to meet the future. And then we are getting all this information, formulating more generic courses based on what they are saying. And then we are going back, formulating course and the course structure, going back to the industry, asking, okay, we have done these courses, what do you think? And then we have some loops about this, and then we have courses that are meeting the needs from the industry. Also, in this discussion, we also have maybe company or people from the companies coming into the courses and giving some seminars and so on to highlight what is the need from the industry. So we have run courses in this way since 2014. So we have large experience in this. And that has been really successful for the industry in the region. If you're looking into the new trend and meeting the sustainable industries need for more flexible and so on, we can see that we have a change in the manufacturing industry today in Europe. We have a number of challenges, market variation, more customized products. We are having this demolition problem where we have less skilled workers, and we need to use the worker in a better way. So that means that we need to move into more automation situation. We need to use the automation maybe to improve the work environment so we can have more elder people working in the industry. We need to solve the economic problem because we need to have a healthy working environment. We need to have good quality. We need to reduce the cost, and we need also to move the manufacturing closer to the customers. And that means that we have also in the automation area challenges that we are reaching these low batches and one size of the batches, so we have one product. That means that we really need to look into the quick setup time and to change the production in a good way. Maybe we also reaching down to a digital reconfiguration of the robots. We can't really have a human coming down, reprogramming robots, taking maybe a week, and then be changing the product every day. So we need to have a fast way to change the production. And then we need to look into what type of competencies for upskilling we need to our workers. So coming back to lifelong learning, what type of courses or competencies are needed in the industry? So what we are looking into is that we are building this, we using existing solution is to force in the flexibility by parameterization. So we have a number of values that we can change, or we are using the flexibility in reprogramming of a system. What we have built here at University West is to work with something called plug-and-produce cell, where we have using multi-agent systems to get a real fast reprogramming of the system. This type of multi-agent system is based on that all parts in the production line get agents with needs and demands and possibilities or processes that they can do things. And then we had developed the standardized process module where we can have PLC, we can have emergency buttons, we can have pressure, compressed air, we can build different things on it, and we can reuse it and update this. So in the cell, it's just that we are changing the cell. We are removing one of these process modules, and then the cell is automatically updating. It's also a very fast way to reprogram the cell. And then the operator, or we have worked with it, so the operator can have a graphical interface to change the production and to control it by an iPad or similar tools. So if you look in the example, we have here an example where we have worked with the wood industry in Sweden, where we are building walls for the houses. This is a demonstrator, so we had reduced the size to 0.5 meter times 0.5 meter. But we are placing different things, we are changing the tools and so on. And normally this is a complex thing to program and takes lots of time. But here it's just done using the graphic interface and this multi-agent system. So here we can see how the robot is fetching the stud or the base for the wall, getting a plywood, changing to get a tool for joining the material together. In this case, it's nailing. Changing tool again, and then we are getting a new drywall that we are placed on the plywood. Changing tool for a screwdriver. And then we are joining the drywall and the plywood to the same part. And now we're going to do drilling. So we are going to drill here, making a hole for electrical box that you can have your electrical wires. And now we are finished. And all the sequence that we have seen here is done without writing any single line of code for the robot, how to handle it or to get any sensor signals or PLC programming. So this is one way that we have worked together with industry to get this type of interactions. Another case that we've done to work with the industry is to make this type of demonstrator where they are identifying some need. We have the possibility due to the projects to buy equipment. And we were approached by a number of companies saying that we are really interested to learn more about smart mobile robots, AMRs. It's like AGV, but it's have a more clever system for doing this. So we were working with the same approach as before. We were setting up an implementation, in this case at the companies. We were demonstrating the possibility to use it, getting knowledge, and then we will transfer the knowledge to the industry. And even if we are at the company here, we have a number of companies that were part of this one and were looking at the results. So using the projects, buying really industrial equipment, starting joint collaboration with the industry, or maybe starting with joint collaboration, identifying the problems, buying equipment, and then doing different type of demonstrators has been really nice for the companies that have participated here. For this company that we were in this case, they have an operator that were working with a trailer with lots of parts, and then he was working like 10 kilometers every day pushing this trolley. And instead, using this type of robot, the company were estimating that the return of investment will be maybe 6 to 8 months, but it were actually shorter. So the investment of buying this type of robot were decreased to 1 to 2 months. Mainly that it were more efficient and so on. So having meetings, discussing with the road companies, and then doing demonstrators, and then generate knowledge has been really successful. Time is flying, and I would like just to talk a little bit about, we are not just working with flexible automation, we're also working with additive manufacturing. And here we can also see that by using the same type of concept, getting the structure funds, region funds, you're working jointly with the companies, we can identify different aspects and different problems, and then we can jointly solve this type of problems. So what we are seeing here is laser beam additive manufacturing with wire, where we have developed a large cell at the university or at this production technology center, where we are doing joint research with the companies to see how this process can be used to build new materials or new product, but also how we can control it, and looking in how to measure data in this type of processes, and how it can be how the process can be used. So this is one example, and then we have another example where we're using instead of using laser, we are using welding arc processes. Different type of methods, but in the same way, we are working with the companies and we are generating knowledge. So I would like to conclude this presentation from the prospect of using different type of research fund by finding the connection between researchers, students, and the small enterprises. We can really see that we are increasing the collaboration with the industry. We can see that we have an increase of students that are participating in our research projects, and we also see that the students have a larger interaction with the companies. And we can see also that the companies are more active in our research than before. And then this type of module or work, I think it's also really important when we're looking into this STARS EU and how we can work in the sustainable industry to really interact between the companies in each region, interact with the students, interact with the researcher, and also collaborate between the different countries. So I think that concludes everything, and if anyone has any type of questions, I will try to answer them.
Hello.
Hello.
I have one question. I am Luis Ribeiro from Bragança Polytechnic in Portugal, and I am when I saw this idea of the sustainable industry, I was very interested. Once I didn't see myself in the other groups, although I work in renewable energies from a mechanical point of view, and circular economy as well. But actually, the research I do and development of works and projects I do is exactly into this area. So my question is, how mature is the idea, and if you are willing to integrate our expertise in this group, although this group looks like it's very pointed into robotics and not looking very well into the design of design process in the conception of new solutions. But that's my question. So, what the clear question is this group closed, or is open, because you presented a very well-defined, let's say, status at this moment, and I had the information that the group was going to be built. So I can see that is already concluded.
No, we are very positive to have anyone that are interested to contribute to be a part of it. This formula or the definition is a little bit of what the text that has been proposed for steering committee, but I think it's just a few parts of a few members that are interested, and we are really interesting to have more people on board. If you're looking at the list that we have, I think that if you're looking at from our side, we're going to have people that are coming from the process part of it in the production, more welding and that type of additive manufacturing. I coming from a robotic and automation part, but we will have a more broader aspect. We have two parts from IPB, Paolo and Yushe. They have a more automation background, I guess. But then we have one from Bremen University, Lars. He has more from the process side of it, more looking to process manufacturing. And then we have Marco, that is a co-leader. He has a more mechanical background. So we are quite broad.
So you already have from IPB?
Yeah, we have one or two, yeah. But I don't see that we have a problem to have more if you're interested.
Okay, thank you.
Yeah, but that's one thing. No, we are not closed. Or we can reformulate things and have discussions and so on. And I think that is really important part in the development of the TIG.
One thing is developing of robotics. Another thing is, from my point of view, from my experience, I'm just telling about my experience, is adapting sustainable solutions to ongoing projects. So,
yeah.
And it's not just plugging in photovoltaics into that. Okay.
No.
So in this case, I'm developing a full industrial line of industrial processing for acorn, because acorn is discovered to be like a superfood, and we need to develop machines for that. But we need to adapt the machines to the forest. We cannot create like a field of wheat and stuff like that. And from all that, we need to adapt the whole perspective. So based on that, we need to, of course, include automation, include robotic solutions, but include a lot of smart design, simplifying things. In a lot of situations, they don't come from putting some automatism. They may come for just changing the design or interpreting, like the way you presented with the cell itself. Just changing the layout of it, and you are able to provide a different service.
Yeah.
So it's from this perspective as well.
Yeah, that sounds very interesting. And by what I mean by development is that it was, our structure and so on, it's not fixed.
Mikael, we must also that we have also a group that work with supply chain and logistics, and logistics is also about how to improve processes in manufacturing. So, and also do it sustainable in supply chain and in the processes in the companies.
Yeah. Do you have some more questions, or comments, or suggestions?
Hi everyone.
Hi.
I'm just a master's student here, but the presentation looks very interesting, so I joined in. When it comes to the sustainable industry, how do you envision the role of AI achieving these resource processes and product development in this area? Like, is the AI factor will weigh in this program or not? Because as you can see, lately we have AI integrated in everything, even in things that we cannot expect. So I'm looking for to know how we how will it be integrated or something equivalent to that?
I really think that we will use AI in most of our processes and so on. It will be integrated. The multi-agent system that I talk about, it is machine learning algorithms and AI that is behind. I think we will use AI for loads of things that are connected to the processes and the industry. So we have to find ways to add it to our production, and it will be added, coming faster and faster, I guess.
Yeah, from what I'm seeing, at least from what we're studying right now, we are trying to integrate it in a lot of things, but as you said, we have to have like more projects and everything, like you're trying to integrate here. Okay, thank you.
Hello, do you hear me?
Yeah.
I'm Klaus Schäfer from Bremen, and I was fixed by your headline, Sustainable Industries, because I'm an urban designer, and I'm very interested on the outcome of your scientist work, because my point of view is how sustainable industries means also to be integrated in the city development, for a city which is more dense and who has more mixed neighborhoods between working and living. How you called it in your words, to come nearer to the customers, I think, and that's a very important point, because it might be that also kind of sustainability is to be integrated in the community, in the built community of the city. That's why I'm here.
Yeah.
Yeah.
And I think that really that you have an important point here, because as you said, we will change the layout of the cities, and we can see that the cities are growing. We can also see that we get more and more population. So to combine the living and the industry, I think it will be very important, even if I don't really know so much about the area, but I can see that we need that type of integration.
Yeah, I think it's another kind of production.
Yeah.
We have no pollution in this case. Our city, how we see it today, is the reaction of a pollution of the 19th century, and we have many laws who avoid the city, from my point of view. And we have little scales. It's also possible in this new kind of industries.
Yeah.
So it could be also better integrated, and we have the wealth or the need of short distances. What means distances of knowledge?
Yeah.
It's also something which is very in advance in the city structure.
Yeah.
I have no question.
Sorry?
That's why I was only fixed. So I know, for instance, I did also my investigations because when I'm working on when we work on existing industrial zones, we try to integrate living zones and more mixed zones to change existing industrial zones to a city, or inverse, we try to introduce in sleeping towns like new towns to integrate there more working places, more industries. That's my daily task, and for this I have also to do many investigations to give arguments to me and my students.
Yeah.
And I know a company or an organization from the States, UMA, do you know them? Urban Manufacturing Alliance.
No, I'm sorry, not.
Who are in the States involving in the process to reintroduce industries, also from trade or small trade in the city. And I know a colleague from London who's, I think, who's very busy in with this headline: "A good city has industries," and did some investigations in Brussels with his students.
Yeah. I think but what you're saying here is really what we can see. I mean, we try to get more and more production inside Europe to close the distances for transportation. And I can see that we not just would like to have transportation from Italy to Sweden. I think it's going to be many companies that are situated close to each other, so they can have a short distance and larger collaboration. I think it's also a little bit about this farming, where we are interested, at least in Sweden, to buy something that is produced close to our town. So we pay a little bit more to have that because we know it's good for sustainability to not have these big transportations and so on. So I think it will be the same also for the industry, that we can see that you have a trademark made in Europe now that is increasing instead of have made in Taiwan, made in China, and so on. So we are bringing things back into Europe, and I think that is one good thing. Then I think what you're addressing about the cities, I think it's also the sustainable industry. If you're looking at it as not having big pipes and so on, we are using green energy to produce part. We will have a nice environment or air condition around it that we have had for a long time. But if you compare it to New Delhi, China, Shanghai, but sometimes you need to have the air pollution is so bad, so you need to have a mask when you're going outside. I think the sustainable industry will really support a community that is growing in a good way in that sense.
There
so
are
it's
also
not just the sustainable, but it's
this
also
fab labs
the
what we have.
outcome is sustainable.
This fab labs what we have everywhere in the cities, more and more.
Yeah.
Also driven by students.
Yeah.
Do you know some more examples of integrated industries?
Sorry.
Do you have some more examples from cities who are integrated in the middle of the street, city, or?
I don't have no good example just now, but I can ask my colleagues and see and send you some information.
Yeah. Thank you.
Yeah, you're welcome. Do we have any more questions? If you're looking at the chat, you will see Elin's email address. And if you are interested to join this TIG, please send her an email and she will add you to the list, or contact list for the TIG. So, and if it is no more question, I would like to thank everyone for joining us today, and also for listening and all the discussion that we have afterwards.